Hello and welcome to Science for Juniors. I am Scientist Radhe Krishna, or SRK as I'm famously called, and this is my assistant Binny. We are doing this experiment to help... Ouch! Burned myself.
Professor, let me get you some ice. It will cool down your skin.
Oh, Binny, the ice is not going to cool my skin. Instead, it's my skin that'll melt the ice with its heat.
But Professor...
You see, it's my hand that will give out heat to cool itself. Binny, you, like many of my students, need to understand the concept of heat and temperature well. You need to understand the difference between these two quantities. So let's enter the virtual world. Heat and temperature. In this module, you will learn about the concept of heat and temperature. If you touch a cup of tea, it feels hot. If you touch ice cubes, we feel cold. It is very important to quantify and measure the difference in warmth of an object. This need introduces us to the concept of temperature. Temperature is defined as the degree of hotness and coldness of an object. Temperature is measured by an instrument called a thermometer. The SI unit of temperature is Kelvin. 273.15 K is equal to 0 degrees Celsius. Let's now learn to calibrate a thermometer. For this, first place the thermometer in ice and mark the melting point of ice, that is 0 degrees Celsius, as lower fixed point of the thermometer. Next, place the thermometer in boiling water such that it does not touch the boiling water that shows the temperature of the steam. The boiling point of water, that is 100 degrees Celsius, is marked as the upper fixed point. The separation between these two fixed points is divided into 100 equal divisions, each representing a temperature difference of 1 degree Celsius. When I was a little boy and fell sick, I was fascinated by these things my mother...
Professor, the thermometer.
Oh, of course. You know that energy only gets transferred from one body to another and never gets lost. So it is with heat energy. When you have fever, the heat energy from your mouth flows to the mercury in this thermometer, which expands from the heat and registers the temperature.
So that means, Professor, that temperature difference between two bodies also shows the direction of energy flow, isn't it?
That is a brilliant observation, Binny. On that note, we get ready to enter the virtual world again. Temperature is often thought to be the same as heat. But this is not true. Though they are related, but there is a difference between them. To understand the difference, consider a glass and a large vessel, both completely filled with hot water at the same temperature. Though the water in the glass and the vessel are at the same temperature, the vessel has more heat as it has more mass. Heat, thus, is a total amount of energy in the substance, whereas temperature is the average energy of the molecular motion in a substance. Consider two glass containers filled with water. One container is at 70 degrees Celsius and the other at 20 degrees Celsius. The molecules in the water at 70 degrees Celsius will vibrate more vigorously than those in the water at 20 degrees Celsius. Why do you think this is so? The molecules in the water at 70 degrees Celsius vibrate more vigorously because the average energy due to the motion of molecules in hot water will be more than that in cold water. Back from the virtual world and into the lab with Binny and me. Oh, Binny, don't touch that. You will get burnt.
Oh, that didn't look that hot.
Ah, Binny, objects at about 54 to 55 degrees centigrade or 130 degrees Fahrenheit are usually warm enough to cause you pain. So please be careful touching things unless you are sure they are near to your body temperature of about 36 degrees centigrade or 98 degrees Fahrenheit. Heat flows when there is difference in temperatures of bodies in contact with each other.
Difference in temperature? Professor?
Yes, Binny. You see, heat is energy in motion. Heat is energy in transit. Heat cannot be said to exist unless there is one system in contact with another system of differing temperature. Let's understand it better. You will now learn how heat and temperature are related. Consider water in a beaker at room temperature. If you heat the beaker, you can easily make out that there is a rise in the temperature of the water. This indicates that as heat increases, temperature also increases. All you can say is that the average energy due to the motion of the molecules also increases. When two bodies at different temperature are brought in contact with each other, heat flows from the body of higher temperature to the one at lower temperature. The flow of heat continues until both the bodies attain the same temperature. At this stage, the two bodies are said to be in thermal equilibrium. Consider two beakers, one containing 250 cubic centimeters of water and the other containing 500 cubic centimeters of water. If you heat the water in both beakers at 100 degrees Celsius, you will observe that 250 cubic centimeter of water takes less time as compared to 500 cubic centimeters of water. You can conclude that where there is greater amount of the substance, the greater the heat required to raise its temperature. Two different materials also require different amount of heat to attain the same temperature.
Oh, sorry I'm late, Professor. The temperature outside was so high. I just had to stop for an ice cream to beat the heat.
Now, Binny, the ice cream's fine, but I hope by now you have learnt not to confuse the terms of temperature and heat. Most people assume that heat and temperature are the same, but you have seen today that temperature represents the measure of average motion of the particles present in the body, whereas heat represents the average energy present inside the body. Now let's talk about something you won't find in the textbook. Do you know that your body has its very own sophisticated internal temperature regulation system?
Our body, sir?
That's right. In the summers when you sweat, it's your body working to maintain its temperature at about 36 degrees centigrade when the air around us is warmer. The blood vessels in your skin expand to take the excess heat to your skin's surface. You also begin to sweat. And as the sweat evaporates, it helps cool your body. So keep yourselves well hydrated this summer. Well, now it's time to warm up our memory. So we go back to what we learned about heat and temperature with a recap. In this module, you learned that temperature is defined as the degree of hotness and coldness of an object. It is measured with the help of a thermometer. The SI unit of temperature is Kelvin 273.15 K is equal to 0 degrees Celsius. Heat is the total amount of energy in a substance, whereas temperature is the average energy due to the motion of molecules of substance. As the heat increases, temperature also increases. Heat flows from the body at a higher temperature to a lower temperature until both attain the same temperature. The greater the amount of the substance, the greater the heat required to raise its temperature. Binny, can you tell me if heat can flow from lower temperature to higher?
Professor, you mean heat flowing from cool to warm bodies?
Exactly. In fact, two of these systems are operational in this room right now. The refrigerator and the AC, Binny, it's electricity that helps them take heat from the cooler inner environment and dispose to the outer warmer environment.
I see.
So that's all from us today. You take care and study your world to discover science every day.